When I have a quadratic trinomial, quadratic means there's an x squared term, and that's my biggest term. Trinomial means there's 1, 2, 3 terms. When I have a quadratic trinomial with no leading coefficient, no leading coefficient meaning it's not like 2x squared or 3x squared. It's just x squared. Quadratic trinomial with no leading coefficient, an empty spot here. Then this technique works. Then the way I factor it is I look for numbers that multiply to my constant and add up to my linear coefficient. So things that multiply to 10, for instance, I could do 1 times 10 makes 10, or 2 times 5 makes 10, or -1 times -10 makes 10, or -2 times -5 makes 10. I look at all these things that I can multiply to 10, and I try adding them up. And I'm looking for the one that adds to +7. +7. So I go down my list, and I realize these two add up to 11, these add up to 7, these add up to -11, these add up to -7. The ones that add up to 7 are the ones I'm going to use. 2 and 5 are the key to this problem. In this version of factoring quadratic trinomials, the version where there's no leading coefficient, all I do is I write 2 and 5 inside of my parentheses, where it's x +5 and x +2. It was +2 and +5 that I used, so I write +2 and +5. Let's do another. In this one, I'm going to look for numbers that add up to 8 and multiply to 16. So I think about all my numbers that multiply to 16, like 1 and 16, or -1 and -16. I know it's not going to be a pair of negative numbers, because how is it going to add up to a +8? So I could kind of ignore those. 1 and 16, 2 and 8, 4 and 4. Those are numbers that multiply to 16. I can stop once I find my right number, by the way. 4 and 4 work. I'm going to use those numbers. I'm going to use those numbers to fill in these blanks. My numbers I found were +4 and +4. In the version of factoring quadratic trinomials where there's no leading coefficient, it's always going to be x, one of my numbers, x, another one of my numbers. And this, by the way, I could rewrite as x + 4 squared. In this problem, I'm looking for something that multiplies to -6 and adds to -1. There's a hidden -1 there. The negative isn't hidden, but the 1's hidden. So I think about things that multiply to -6, like 1 and -6, or 2 and -3, or 3 and -2, or 6 and -1. And I think about what they add up to. And I'm going to choose the one that adds up to -1. That's going to be this pair right here. 2 and -3 are going to be my numbers. I have x, and I'm going to fill in the blanks with +2 and -3. Here I'm multiplying to 7, adding to -8. Numbers that multiply to 7 are 1 and 7, or -1 and -7. The pair that adds up to the -8 I'm looking for is -1 and -7. So when I factor it, the numbers I'm going to use are -1 and -7. I can check my answer, by the way, by redistributing. I can do FOILing. So first, I do x times x, and I get x squared. Then I do outer, so I do x times -7, and I get -7x. Then I do inner, and I get -x. Then I do the last ones, and I get +7. That is an overwhelming amount of color here. let's make it just slightly more overwhelming. So if I combine this, my like terms here, I can make it x squared minus 8x plus 7, which is what I start out with, x squared minus 8x plus 7. So I know I did this right. This is the correct factoring right here. Whoops, that's not the problem I wanted. I guess that's it.